Welcome to this lecture. In this today's session, we're going to see the sizing of 10 kilowatt of on-grid solar power plant. It means how many panels were required and how we were connecting these panels in the series and parallel combination according to the NPPT basis. One by one, we're going to proceed for this section. Basically, when we are going to select any kind of the solar panels, we have to check what is the maximum peak capacity the solar panel is having. Also, we have to select what is the maximum voltage the solar panel is creating, what is the maximum current the solar panel is creating over here. In the market, there are number of manufacturers are there who is providing the solar panels, out of which for this case study we have selected the Vikram solar panel and typically of 315 watt peak of a solar panel. So basically whatever the data has been given in the electrical data sheets of the Vikram solar, it is given for 1000 watt per meter square solar radiation and also the standard test temperature of 25 degrees centigrade. So basically the 315 watt peak of solar panel producing the 37.5 maximum voltage and 8.40 maximum current for the particular 72 number of solar cells when they were connected in the series combination. When we talk about the efficiency of this module, it is 16.23% they were giving the efficiency. We just note down this particular parameter for further calculations. Second thing, we need to select the inverter, for which inverter we have to proceed for the build-up of the particular solar power plant. In this section, we are going to select the Sungrow inverter having a capacity of 10 kilowatt capacity. So basically in the Sungrow inverter, we were choosing here the 10 kilowatt of a capacity. Ultimately, whenever we take out the specification sheet of the any inverter, some of the parameters we have to always focus in this specification sheet. First parameter is the what is the maximum input voltage. In this case, it has been given as 1100 volt. Then we check NPPT voltage range actually. NPPT voltage range is very much important because when we are deciding the minimum and maximum number of the solar panel will required, in this case this inverter is giving the minimum voltage or acceptable range of the voltage is 200 volt and the maximum voltage basically it is the 800 volt this particular inverter is accepting. Second important thing, we need to focus on the number of NPPT inputs the inverter is having. NPPT inputs is nothing but basically when we take any kind of the inverter over here, we can connect the two number of the strings of that particular inverter over here. So let's say this is a particular inverter model if we selecting for the Sungrow. So this is our first connection, we call it as a NPPT number 1 and we say the second connection we call it as the NPPT number 2. Basically the NPPT nothing but it is a maximum power point tracking algorithm which has been fitted inside the inverter so that whenever we were connecting the one string, two strings per NPPT, it will track the maximum amount of voltage and the current, in short the power from the solar panel, so that we can create or we can generate the max to max amount of the solar power we can capture in this inverter actually. Most of the inverters were having the 1 NPPT, some of the having 2 NPPT, 3 NPPT likewise. As per the NPPT range is increasing, we can say this inverter we can go to use for the particular cases because we can track particular string to string with the help of the individual NPPT. The feature has been given by most of the inverter. Then we have to select the particular maximum input voltage and the current also. Current range has been given over here 11 ampere for 1 NPPT, again 11 ampere for the second NPPT. Total 22 ampere we can feed to the particular inverter and the maximum number of the rows or the string we can connect to the inverter is up to one number of the string. So basically there are number of configurations are having up till for the 10 kilowatt of the solar power plant. We just focus on this data sheet where the two in NPPT inputs has been given and per NPPT we have to connect the one number of the string in the series combination. So basically the current it should be acceptable per string wise, it is 11 ampere and 11 ampere. So just two parameter, that is one say the voltage parameter and also the current parameter, and last two parameter is the NPPT and number of strings per NPPT. We just note down from this typical data sheets and then we'll proceed for the further calculations. In this table actually we have summarized the all parameters over here. The inverter which we choose is a Sungrow inverter of 10 kilowatt of a size. The number of NPPT, it has been allowable up to 2 NPPTs. Number of the strings is 1 per NPPT. Voltage will be 200 volt up to 1000 volt, and the current per NPPT will be 11 ampere plus 11 ampere. It has been acceptable. So total 22 ampere of the current it has been acceptable by the Sungrow inverter having the 10 kilowatt of the capacity. Again we have chosen this panel of the 315 watt peak. Also the maximum voltage will be 37.5 and maximum current of this panel is 8.40 ampere. We just note down this parameter and we proceed for the building of the particular solar power plant. So basically when we proceed actually of the drawing of a diagram, we need to focus on some of the formulas, how to calculate the number of solar panels. Total number of solar panel required, we can calculate by this formula, that is installed capacity divided by the panel rating. So basically installed capacity we know it is 1000 watt peak, that is 10 kilowatt, and the panel which we are rating actually we were selecting, it is 315 watt peak of panel we were selecting. So ultimately by this calculation we came to know there are total 32 number of the solar panels we required actually. 32 number of solar panels we required. So we just take these panels and we proceed for further calculation. The number of the solar panel per NPPT basis we can calculate by this formula. Total number of solar panel in our data sheets or as per our calculation divided by the number of NPPT inputs accepted by the inverter. In this case this inverter is having the two number of the NPPT input connections has been given actually. That is why we just dividing this number of panel by 2. We were getting 16 number of panel we can distribute string to string wise or per NPPT wise. The next thing is what, once we have decided how many number of panel we need to connect per NPPT basis, next is calculate the minimum number of panel we should connect in the one string actually. It means that in a one row of a solar panel actually, this row we were connecting in the series combination. So how many number of minimum panel we should connect in the series combination so that its voltage creation will be in the range of acceptable voltage range of the inverter actually. So we can calculate with the help of this formula, which is minimum voltage required upon the voltage of the solar panel. Minimum voltage of the inverter is 200 volt and the voltage, that is maximum voltage of the panel or the voltage of a panel, we can say it is 37.5 volt actually. Just do this calculation, you will get minimum 6 panel we require to be connect in the series combination. Again, also we have to calculate that how many number of maximum panel we should connect in the series combination in one row of the connection actually. So we can go for this formula, that is maximum voltage required divided by the voltage of individual panel. Again this maximum voltage we can get it from the data sheet of the inverter. Here it is 1000 and we just divide by 37.5, which is the voltage of the solar panel. After doing this calculation, we are getting max to max 27 number of a panel we require to be connected in the solar panel in such a way that their voltage might go beyond this maximum limit. So whatever the panel, that is optimum number we were connecting in the series combination, that should be lie between these minimum panels and the maximum panels. Next thing, we'll focus on the number of the solar panel per string. It means one row, how many number of the optimum solar panel we should connect so that their voltages, their current should be in a range of acceptable range for the inverter which we were selecting over here. So to calculate this optimum number, we just take either the average of this 6 plus 27 by 2, that is of the 6 plus 27 by 2, we will get 16 number of the panel is optimum panel. Rather, we can also say how many number of the string per NPPT is allowable by the inverter. Just divided this number of the solar panel per NPPT that we have calculated here actually. We take this value over here divided by 1, that is number of strings per NPPT. We'll get automatically get how many number of optimum panel we should connect in the series combination, that is 16 number of the panel. Further, we're going to proceed for the next drawing of the diagram. So let's say we are drawing the string number 1. In the string number 1 is first panel is connected to the series combination with the second panel. Again this is connected with the third panel. Again it is connected with the fourth panel. So likewise total 16 number of the panel we were connected in the series combination in the string number 1. So this is our string number 1 and the panel combination is in the series. remember that whenever we were connecting the panel in the series combination, their voltage is getting added over here and the current will remain same. So when we talk about the individual voltage, actually the voltage of one panel is 37.5 volt and the current of each panel will be 8.40 ampere actually. In the second string, actually again we have the 16 number of the panel that we were connecting in the series combination over here. So this is our 16 number of the panel. Again this is our string number second actually. String is nothing but the row of the panel which is connected in the series combination. This is string number second. So ultimately the output of this string number 1 we were giving to the NPPT number 1, and the output of this string number second we were giving to the NPPT number second, and this is our actually the inverter has been located over here. So this is our inverter. So basically this is, we call it as the maximum power point tracking connection number 1, NPPT number 1, and this is our NPPT number second. So this is our one connection, this is our second connection. So when we talk about the voltage acceptability actually, so in this case individual panel is having the voltage of the 37.5 volt and the individual current is equals to 8.40 ampere. So whenever we were connecting the panel in the series combination, 16 number of panel is connected in the series combination. So basically the voltage of the whole string, when we say this voltage is nothing but 16 number of the panel multiplied by the voltage of the individual solar panel. So we get 16 multiplied by 37.5 volt. This much is the voltage of the individual string. And again the current of the individual string will remain same, that is 8.40 ampere. And why? Because this series connection we are doing over here, and in series connection typically the current will remain same over here, only voltage is getting added over here. So once again when we draw the diagram on this side, actually this is our inverter we were selecting, that is our Sungrow inverter we are taking. So this is our NPPT output number 1, input number 1, and this is our NPPT number second. So voltage of this string 1 is equal to 16 multiplied by 37.5 volt, and the current is equal to 8.40 ampere. So basically this individual voltage, it should be lesser than the acceptability range of this inverter actually, which is 200 volt up to 1000 volt. So we can say whatever the voltage is coming, it is coming all near about 600 volt approximately. So the 600 volt actually, after doing this calculation, it is lying between the range of minimum and the maximum. So we can say this is okay for the connection. Again when we see this current, actually current per string, this current per string should be also lesser than whatever the individual acceptability range of the NPPT, which is 11 ampere has been given in the inverter actually. So that is why whatever the current we are feeding per NPPT, whatever the voltage we are feeding per NPPT, this should be the acceptable range of the inverter data sheets. So likewise we can draw this particular connection over here. We just summarize all these in this one data sheet over here, that is the one string having the 16 number of solar panel were connected in the series combination. So the voltage per string, we can say number of panel, which is 16 multiplied by the maximum voltage of the individual panel, which is say 37.5 volt. Ultimately we are getting 600 volt per string actually, and the current per string will be 8.40 ampere, which is the current of the individual panel. We can say it is a individual panel current. Again when we summarize this data at the NPPT level, so the one number of the string is connected to the NPPT number 1, and the voltage per NPPT will be individual voltage of the string, which is 600 volt, and the current per NPPT will be number of the string we are connecting in the parallel combination multiplied by the current of the individual string. Here the number of the string is only 1 to the NPPT, and the current of the individual string is only 8.40 ampere. So the NPPT current will be 8.40 ampere only. So likewise we can calculate what is the voltage and the current is going inside the per NPPT basis, and whether our connection will be feasible for connection or not. So when we say, actually we just have to check the voltage and the current over here. Whatever the voltage we got per MPPT, it is within the acceptable range. Whatever the current we got, which is also within the acceptable range. So we say whatever the calculation what we have done, whatever the diagram that we have done, it is okay for the connection over here. And ultimately when we see in the AutoCAD diagram, we can draw such a diagram over here, where the panel number 1, panel number 2 up to the panel number 16 were connected in the series combination, and their output has been given to the NPPT number 1 over here. Simultaneously for string number 2, 16 number of panel were connected in the series combination, and their output is given to the NPPT number 2 over here. So likewise we can size the 10 kilowatt capacity of the solar power plant.